Welcome to this documentary titled NRF 2020 STEM Accessibility Project, a documentary film produced from the NRF 2020 research grant given to Dr. Sariat Ajibola Adelakun, the principal investigator, and the 4 other co-investigators who are Dr. Chukwuka Evangeline Udona, Mrs. Abdulsalam Aminat Obakume, Mr. Shitu Musibau Adeniyi, and Dr. Kehinde Michael Adeyinka. The grant was given in September 2021, and the research was duly carried out.
S.A. Adelakun, to tell us why we are here and give brief.
Collaboration and innovation aimed at breaking down the barrier and the potential of technology to transform lives and therefore and level the playing field, ensuring that every aspiring mind
to effectively disseminate the findings of the NRF 2020 STEM Accessibility Project, a documentary was produced. The documentary showcases the major output of the project, including the equation format converter, tactile diagrams / textbooks, and the tactile library website, alongside testimonies from blind and visually impaired students and teachers.
Let me fill it. Tactile diagram for junior secondary school mathematics. The first one is net of a keyboard. From the filling, we can see that a keyboard has 12 sides.
It was shared with key stakeholders such as JAMB, WAEC, NECO, and the Federal Ministry of Education, and also made publicly available on YouTube and other social media platforms. This approach will ensure broader visibility, policy engagement, and lasting advocacy beyond physical stakeholders' visit. The title of the research project is Technologies to Increase Access of Blind and Visually Impaired to Science, Technology, Engineering, and Mathematics STEM in Nigeria. The initial objective of the research is to develop 3 softwares. One of it is equation format converter. Then the second one is the screen reader with local accent, that is with Nigeria accent. Then the third one is, we call it DMAP, which allows persons with visual impairment to interact with diagrams. That is one of the objectives, developing 3 software. Then the second objective is white. That is using 3D models, 3D modeling, and 3D pen to produce materials, resources that are either too big, too small, or dangerous, that cannot be brought to the classroom, even if you want to use original objects. This documentary specifically is prepared to introduce the product of our research to stakeholders. One thing is known that make STEM subjects inaccessible or difficult to blind and visually impaired. We know science is mostly visuals and requires sight to observe, to feel, interpret. So, during our research, we have the following output. One is the equation format converter that we develop. See, this equation format converter allows a blind or student with visual impairment or persons with blindness to interact and have access to equations.
To access mathematical content or mathematical equations, go to the search box.
Search box edit, type a text.
Just type EFC.
EFC app. Press right enter. Equation format.
Hit enter.
Choose file button to activate.
Okay.
Press space
Yeah, instructed me to choose the file. I will press space bar on that button. So
open dialog. File name edit combo.
that is instruction to input file name. The file I want to access is save it with spoon.
SPOON.
So I will use my tab key to move on.
Spoon. Files of type combo box. Word document left parent star docs right parent 1 of 2.
I move on. My tab key.
The arrow keys alt plus T file. Open button to activate.
Instruction to open the file.
Space unavailable. Choose file button.
So I must use this app to convert the file so that the converter will be able to read it well for me. I move on.
Convert equation button to activate. Press space bar alt space.
So the app has converted the equation. So I will move on. Has converted the file. So I will move on to the file.
Reset display button to activate. Press space bar. Save button to exit EFC ASCII text.
So this is the file.
ASCII text output edit read only. Some of the equations and formulae that can be accessed by the equation converter are as follows: contains text. Use your reading keys to read the text.
I will use my down arrow.
Quadratic equation x caret 2 plus bx plus c equals 0.
That is a squared plus bs plus c is equal to 0.
Where a, b, and c are constants.
Where a, b, and c are constants.
X equals left parent dash new left parent b caret 2 minus 4 and right parent slash 2.
So the value of s equals minus b plus or minus square root of b squared by 4ac everything over 2a.
Simple equations x plus 6 equals 8.
Some of the simple equations are s plus 6 is equal to 8. Let me repeat that so that you can hear it well.
Simple equations x plus 6 equals 8.
So another one.
Y minus 3 equals 2.
Let me repeat that one.
Y minus 3 equals 2.
Another one.
Simple interest equals left parent bxrxt right parent slash 100.
That is simple interest. Principal times time times rate over 100. Let me repeat
Simple
that.
interest equals left parent bxrxt right parent slash 100. More simple equations if 2x caret 2 equals 25, what is values of x?
If 2s squared is equal to 25, what is value of x? Let me repeat that.
If 2x caret 2 equals 25, what is values of x?
That's all.
You know, there are equations in mathematics and there are equations in other science subjects. For instance, we have quadratic equation, we have simultaneous equation, we have even fraction at the primary school level. Fraction. The screen readers are designed to read vertically. They are designed to read from left to right. So if there is a question in a document, the screen reader will read the top line before it comes back to read the bottom line, the numerator, before it comes back to read the numerator. This will confuse persons with visual impairments. But with the equation format converter, it allows it to convert the equations in any document, any Word document, into a form, ASCII format, that it will be read out to persons with visual impairment in a way that they will understand what is being read. And when they understand what is being read, then it will make it easy for them to solve such equations. As illustrated in the attached video, the person with visual impairment that is operating that system is able to interpret, understand the equation. There are equations in mathematics, there are equations, like I said before, in all other subjects in science, other STEM subjects. We removed the aspect of designing software two software, the screen reader with local accent. If we look at the equation format converter that we developed, what remains that we need to do is developing the screen reader that have local accent, such that the pronunciation of some words will be clearer to students with visual impairment. We removed this software from this current research because the research was overpacked, and because of inflation and other logistics, we have to remove it because it's not something that we can. It's a big project on its own. It's not easy to design it and evaluate it with the current, and we are appealing that we be allowed to submit, and we are prepared to resubmit a proposal to develop the sign language. This will be a final, not a final, it will contribute greatly to access of STEM discipline to persons with visual impairment. And by the time we develop the screen reader with local accent, I know nothing will stop. We will develop it in such a way that it will be easy. It will be able to deploy. It will be able to be used in conducting CBT examination for students with visual impairment. In the proposal, we are hoping to test run the screen reader with local accent in all the geopolitical zone in Nigeria, such that, and as we are testing it, it will be familiar to students with visual impairment, so that by the time we finish that screen reader, JAMB and the other examination bodies will be able to test the student with visual impairment in CBT, in computer base. However, the tactile diagram 3D models, and STEM kits will be used to support to interpret the question appropriately to them, so that they will be able to for instance, what I'm trying to say is that when the software equation format converter is installed on the system, so when the student with visual impairment access the question with the screen reader with local accent, it will read the question to them. And once the student come across an equation with the equation format converter, it will be accessible to the student. So the student being examined, you'll be able to use it. And when it comes to diagram, the diagram will be provided in tactile form. So you will feel it. As you feel the diagram, you will be able to answer the questions still on the CBT. If it needs a model, a diagram, a map, we use 3D machine to produce map. We use it apart from once there is anything that is we can combine the provision of it in tactile diagram and in 3D model. And the ones that are better provided in 3D will be provided. The one that will be better in tactile diagram will be provided. And some they may have both. Once they fill the diagram and the 3D model, they will be able to answer all the questions that involve diagram. And in essence, sometimes some students develop visual impairment while studying STEM discipline. We have some of them studying nursing, we have some studying engineering, we have some of them in physics and chemistry. What usually happens is that they leave the course, they become depressed, and later some make up their mind and go back to study special education. Again, for the STEM kit, the STEM kit was purchased and used during the training. We use it to train teachers from 7 states in the Southwest and Kwara. We trained them, the teachers in the primary school and the secondary school. They see that this STEM kit can make mathematics accessible or calculations accessible to persons with visual impairment. For instance, the use in teaching is different from the use in examination. When the teacher is teaching mathematics, for instance, each of the student with visual impairment will have the board and the tiles.
Mathematics board that visually impaired learners can use to solve arithmetic. We do use this one so that for them to be able to feel it when we are in class. So when you are given any example to work on, you are going to use this kind of board to explain it for you. So when you are to solve it by yourself, you will be able to transform into braille. So now this is how board looks like. It is foldable board. So when we open it, we have, we taught ourselves that in mathematics, if you want to bring A to 0, we are going to make use of A to J. Just add numeral sign 3, 4, 5 and 6.
3, 4, 5 and 6.
Yes, to indicate the numeral sign, and add A to J to form your A to 0. Do you get that? So this is our 1, as you can see. Yes, this is our 1.
This is our 2.
This is our 2. This is 3. This is 4. This is 5. This is 6, 7, 8, 9,
0.
yes.
J.
Now, yes, we will now leave this one and move to how to solve simple equation today. You know, we've already discussed about how to solve simple equation. So now let's take a look at this equation. To firstly fill it, I want you to pronounce this term for me.
Let me fill it. Let
Yes.
me fill it well. This is let me. Okay, this is numeral sign b, which is 2.
Yes.
So this is x.
Yes.
This is x.
Yes.
Letter sign x.
Exactly.
Okay. This is plus.
Yes.
That
So as the teacher teaches the quadratic equation or teaches 2x plus 4 equals to 0 or 5x squared plus 3x equals to 0, solve. So as the persons with decided in the class work the calculation in their exercise book, persons with visual impairment will arrange the tiles on their board. So as the teacher moves around to see what decided are solving the questions they solve, the teacher will get to the table of the student with visual impairment and see what they have solved. They will see what they have solved. You know, if the students make mistake or they don't understand, because the tiles have print labels and has braille label, so the student with visual impairment will use the braille label to arrange, to work, to solve the equation, like the one that is shown in this attached video. It will show. So if the child make mistake, the teacher, the sighted teacher teaching, will use the print label that is on the braille to arrange it to guide the student with visual impairment, so that the student with visual impairment will learn. So it has removed the communication gap between the sighted teacher teaching mathematics or teaching physics. If the teacher is teaching physics or is teaching calculation of power or force is equal to ma, has decided put F equals ma and substitute m and a to get the force, or substitute first to get the acceleration before resubstituting in F equals to ma. A person with visual impairment we also arrange the F equals ma and put the values in on the board. So the teacher will be able to see what the teacher is solving and what the student is solving. That is for teaching. Then for assessment what the teacher is teaching, when the person with visual impairment finish solving one question, the teacher can take a picture of the drawing, so that after it will be able to print and mark. This is better than situations where a person with visual impairment, a student with visual impairment, is asked to do it in braille, and they will take the braille paper and give to a teacher that is also visually impaired. So that teacher that is also visually impaired will now translate, and put what the student writes. In many cases, what they transcribe or translate sometimes differs from what the student puts down. So this is also a way out. Another step, another resources that has also make teaching and assessment of student with visual impairment in calculation easier. During assessment, if this board and tiles are available for students with visual impairment, they can arrange the tiles. And once the tiles is arranged, they can snap. The second aspect is the tactile diagram. Tactile diagram. Tactile diagram is also very, very important. You know, there are so many diagrams, not only in STEM subjects. There are so many. A student comes across diagrams in so many subjects, but it's predominantly in the sciences and mathematics. We talk of shapes, we talk of so many diagrams in mathematics, circuit theorem, many topics in mathematics involve diagram. And we cannot remove diagram from mathematics and sciences. Sometimes schools and examination bodies give bonuses of to persons with visual impairment on questions that have diagrams. You agree with me? There are so many questions have diagram. So many requires a person with visual impairment to have a special knowledge of a particular question before they will be able to answer the questions. So this particular tactile diagram that is used that we are introducing have another unique properties. The unique property is that makes it different from the existing ones on the internet, which has already been presented in conferences in the US and UK, and the participants accepted, adopted, and praised the researcher for developing the tactile diagram. The tactile diagram is of different types. This particular one is very unique in the sense that apart from diagram being many in STEM subjects, in mathematics and all this in the STEM subjects, persons teaching mathematics and science in the primary school, in the secondary school, and in tertiary institutions are mostly cited. And sighted don't know Braille. The student with visual impairment they are teaching cannot see what they are drawing. So there is communication gap between the teacher and the persons with visual impairment, the student with visual impairment. So this particular tactile diagram have print label and Braille label. So when the teacher use it to teach, the sighted teacher will see the print, and the blind student, the visually impaired, the student with visual impairment will be able to feel the Braille. So when it is being used in teaching, it makes it easy for teachers in our inclusive schools to be able to teach STEM subjects. They should be able to use those diagrams to teach students with visual impairment along with sighted peers in the same class. So the diagram, the tactile diagram is being used by a visually impaired that is shown on this attached video.
4, Unit 3. Fractions of circle. Number one, hole.
Yeah, stop. So you see that hole, as you can feel the hole, you can see that it is a blank circle. That is why we call it whole. So when we move on to another aspect, you'll be able to differentiate between whole, half, 1/3 that you have been explained so far. So now let's move on to the another one. This is number two. Yes.
So the circle is divided into two.
Exactly. You can see that the circle, once one side has been shaded and it has been raised. Feel it. This is the shaded part that has been raised, and you can see another side that is what? Blank. So these two sides is called 1/2. The 1/1/2, which is 1/2. So the side that has been shaded is representing 1, while the other side represent the whole circle, because the whole circle is divided by 2 and the shaded part carries 1. Let's move on to another one. This is
number 3.
Thank you.
The circle is divided into 3.
Exactly.
So which means 1/3.
Thank you. Feel it very well. This is the shaded part here. Thank you. You can see another part and another part, making how many? 3. So we have 1/3 or 1/3. So that is it. Move on to number 4.
Number 4. The circle is divided into 4, which means 1/4.
Here you can see feel the shaded part. Another side is here.
Yes.
We have another side here and the side here. So they divide the whole circle by 4. Having made the shaded two sides, it will give us 2/4. But the shaded part, that is why we have 1/4. Do you get that?
Yes.
Okay, let's move on to another one.
Number 5. The circle is divided into 5. So we are having 1/5, 1/5.
Thank you. Feel it very well. This is the shaded part. 1, 2, 3, 4, and 5. So I want to ask you a question now. Let's take it for instance that this whole circle was divided into 7, and 4 were shaded. What answer are we going to have?
We should be having 4/3.
That 4 over what?
7.
That's it. You want to clap for yourself. That's it. So let's move on to another one.
Okay, number 6. So the circle is divided into 6.
Can you show me the shaded part?
Yes, here is it.
Thank you. How many sides do we have? Now feel how many parts are shaded and how many parts are blanked.
We're having just only one part shade, while we're having 1, 2, 3, 4, 5, which means we're having 5 left, which means 1/6.
Thank you.
So, and we package the diagrams according to classes. So we see for junior secondary schools, we see for primary school, and we have some as teaching aids that can be used by teachers when they are teaching a particular topic in a class that have persons with visual impairment. So these are some of the examples. Thank you for going through the documentary of our research. I am Dr. Sarah Adelakun, the principal investigator, and I want to state that we wish the stakeholders will consider adopting these outputs of our research to achieve our aim of making STEM disciplines accessible to blind and visually impaired in Nigeria as it is in other parts of the world. We are prepared to submit the aspects that was removed from this current research. That is, developing the screen reader with local accent, with Nigeria accent, which will enable the blind and visually impaired hear, listen, interact with the system. This will enable them to be able to take part in CBT in all our institutions and in all examinations. The second aspect too is also being prepared for the new concept note that is making it possible for blind and visually impaired to take part in the practical component of STEM. All these are necessary. By the time we finish these two other research proposals that is being prepared to be submitted in the new concept notes, we hope blind and visually impaired will have equal educational opportunities, which is the mission of the government, which is the mission of all the examination bodies, especially the JAMB. Thank you.
My name is Dr. Evangeline Udonna Chukwuka, co-researcher for the third fund sponsored research study on increasing access for science, technology, engineering, and mathematics for learners with visual impairments.
My name is Aminat Obakume Abdisalam, a member of the research team in a third fund sponsored research titled Technologies to Increase Access of Blind and Visually Impaired Students to Science, Technology, Engineering, and Mathematics in Nigeria.